Okay, the next speaker is Zhang from Synchrotron SOLEIL. She's going to talk about PandABox, a multi-purpose platform for multi-technique scanning and feedback applications. Xu is an electronics engineer in the electronic control and acquisition group of Synchrotron SOLEIL. During her 5 years at SOLEIL, she has mainly worked on projects based on FPGAs and embedded systems.
Thanks for the introduction. Hello everyone. So yeah, I'm Zhang from Synchrotron SOLEIL. I'm going to present the PandABox project, which is a multi-purpose platform for multi-technique scanning and feedback applications on behalf of SOLEIL and Diamond project team. An overview of the project. So I will start by a quick introduction of the project, and then I will talk about the hardware designs and the firmware and software architectures. And thereafter, I will mention some applications ongoing at SOLEIL with PandABox. And in the end, a conclusion. So the project aimed to overcome one of the main challenges for control and acquisition, which is to synchronize sensor and detector acquisitions with mechatronics systems to acquire useful data and to perform as fast as possible continuous acquisition to save time. So the initial objectives of the project is to connect the motion system with data acquisition systems for continuous scanning applications. So the motivation of the project was initiated to overcome the obsolescence problem and technical limitations of our in-house developed products. And in the meanwhile, we wanted to maintain its modularity and improve its performance. So the collaboration was established between SOLEIL and Diamond to share the experience and the development tasks. Okay, I will talk about some hardware designs. The hardware was designed in a very modular way and flexible way. The platform was developed around off-the-shelf PicoZ, ARPANET PicoZ module based on a Zinc SoC, which embeds an ARM processor and IPG-based program logic. And around this module, we implemented some modules and I/O interfaces, communication interfaces, and besides of that, we used another FPGA for slow controls like onboard temperature, voltage monitoring, or I/O configurations, etc. So here, what it looks like. And so from the real panel, we can find the 4-channel encoder input and outputs, and from the front panel, we can find the main digital input outputs and the communication interfaces. And in the rack, we find the different modules mounted on the conveyor belt to realize these interfaces. And we have equally an FMC low pin count slot to receive an optional FMC mezzanine card to extend the platform capacity and functionalities. So the prototype was entirely tested at Diamond and SOLEIL with the first released firmware. We also tested the fiber optic transceiver with different bit rates over the SFP ports. And however, we observed an overheating problem on the commercial grade PicoZ with internal developed firmware which has a heavy load. So it's a recent problem. So while searching for a better heatsink solution, we are currently employing the industrial grade PicoZ. Okay, I'm going to the firmware and software part. So for further information, you could find more details in the poster section with this reference. And the firmware was developed also in very flexible and modular way. We implemented in the FPGA layer firmware structured into numerous functional blocks. And on the ARM CPU part, we implemented the TCP server, which acts as a bridge between the between the FPGA firmware and the remote clients. It published two endpoints, one for configuration control and one for data capture. These two layers are tightly coupled through a common set of configuration files. This is a fully reliable architecture, which means we can change the wiring of the functional blocks and their parameters during the running time. Okay, in the firmware, all the functional blocks are interconnected with each other through via a common bit bus and position bus. In the default firmware, we implemented some logic blocks and position processing blocks. However, some new custom functional blocks can be added to adapt new requirements with the help of the development kits available on Open Hardware repository and a Git tool developed by Diamond. That makes the integration of these new functional blocks quite easier. So here a software architecture for PandABox. Over the TCP server, the TCP server is made to interface with either Tango or APEX softwares or web server. So on top of the TCP server, there exists a WebKey for visualizing and wiring the functional blocks of the firmware and setting their parameters. So here is an example of our continuous scanning application with an internal developed functional block, and its parameters and input-output information are displayed here. This is a very useful tool for to build customized applications. For the control softwares, at SOLEIL we created three types of Tango device servers. One for hardware configuration and hardware and monitoring. One is a generic device server to create customized interface. And a third type of device servers for dedicated applications like continuous scanning applications, quick exaf applications, etc. And here an interface of APEX driver for area detector application, which is running at Diamond. Okay, I will talk about some applications at SOLEIL ongoing with PandABox. The first hardware encoding processing application and continuous scanning application were the basic requirements of PandABox project. They are currently managed by our last generation product, SPIRITbox. So to maintain the service continuity, we need to replace these functionalities by PandABox in first. And in addition to that, we implemented a feedback application that I will talk a little bit later. Yeah, so this is a classic continuous scan architecture. So FlyScan or Markov framework will control the whole system over the Ethernet bus. It will control the motion systems and acquire the sensor and detector informations over the Tango or APEX bus. PandABox will require encoder signals from motion axis or interferometers, and it will generate software or hardware triggering signals to synchronize the acquisitions with motion systems. And yeah, this is an example of the feedback application implemented at SOLEIL. This is an upgrade improvement of the real-time control system for fast beam attenuation with an expert 2D two-dimension detector. So from the global architecture of the control system, we find the two main elements. One, the detector intensity analyzer, which performs cyclic estimation of the photon flux, and the control module will adapt the beam attenuation continuously according to the analyzer result. And for the moment, these two modules are implemented on a prototype platform and a CPCI, a compatible PCI card based on APG, which is currently obsolete. So from this upgrade, we can take several operational and technical advantages. We are currently in the end of the first step of this upgrade project. And we have almost migrated the analyzer firmware from Altera FPGA to the Zinc SOC. And we are making the test with the detector on the beam line. Here shows integrate logic analyzer, capture the detector data frames over the SFP optic interface. Okay, the conclusion. The initial objectives of the project have been achieved with a resulting system very flexible, open, extensible, adapted for multi-technique scanning and feedback applications. We need to finish the ongoing development for the Tango devices or the first applications, and we hope to commissioning the flight scanner application as soon as possible. And we need to prepare also the call tender for the hardware supplies. The DTAC is currently integrating their FMC ADC modules into the PandABox platform. On the side of Diamond, they have already deployed the PandABox on 4 beam lines. And the rollout project is being planned for the rest of the beam lines in the couple of months. For both institutes, they keep improving the platform based on their experience. So we'd like to thank people who are involved in this project, and also people who are not listed here, as SOLEIL, for example, the detector group, IT group, and I believe the same for Diamond side. And we publish the project on the Open Hardware repository. Any suggestions and new ideas of the applications are very welcome. And thank you very much.
Time for questions?
Hello. You mentioned you were having some problems with the heat sink.
Yeah.
Is your current heat sink extruded or cast?
Sorry, extruded or?
Cast.
Means cut?
Cast. Melted into a mold in the particular shape of the
Yeah, it's on the SOC of the PicoZ module. And we only have this problem when while running some very heavy loads firmware. And we have encountered this problem very recently. We are searching for a better solution. Is that your question?
No, my question is, the current heatsink that you're having the problems with, was it manufactured using an extruded process or a cast process?
Can I just say, currently the sink is fitted with no heatsink. That is why there is a problem with the heating. That's all I want. You know, currently there is no heatsink fitted to the device.
Okay, I was going to say that you could move to a cast heatsink because you generally get about 25% improvement for the same.
No, we've ordered some heatsinks and they're fitted. We haven't done that work yet. Yeah. We got quite a long way without a heatsink, and then SOLEIL have discovered that it's a good idea to have a heatsink.
Okay, thank you.
Any other questions? Okay, let's thank the speaker again.